Hello friends, this video on aldehyde ketones carboxylic acid part 31 is brought to you by examfear.com. No more fear from exam. Right? So now we'll talk about the methods to prepare, the chemical reactions involved in the carboxylic acids. So there are some chemical reactions where we have the cleavage of COH bonds. If you see, we have two bonds here. Right? So in one case, this bond breaks. So this is what I'm talking about. This bond breaks. So where we talk about the formation of anhydride, we'll talk about esterification, we'll talk about the reaction with PCl5, PCl3, SOCl2, we'll talk about reaction with ammonia, and then we'll talk about the reaction involving COH group altogether. We'll talk about reduction, we'll talk about decarboxylation. We'll also talk about substitution reaction in the hydrocarbon part. We'll talk about halogenation, we'll talk about ring substitution. So these kind of reactions we'll talk about. Let's start with anhydride formation. Let's start with anhydride formation from carboxylic acid. So if you see here, if I take any carboxylic acid, like two of the carboxylic acid, and I heat this with some mineral acid, HCl or something, so water molecule is lost, and what you get is anhydride. This is what you get, right? For example, if you take ethanoic acid, you'll get ethanoic anhydride. For example, you take ethanoic acid, you heat this with acid, you get ethanoic anhydride. Let's see how it works. So let's see this reaction mechanism. So I have ethanoic acid. It happens in the presence of H plus. So let's suppose this H plus goes there. This carbon, if you see, this oxygen is more electronegative, slightly negative charge, carbon slightly positive charge. So first thing that will happen is this oxygen will attack this H plus. So what will form is CH3, COH and a positive charge. Now this carbocation will attack this now. If you see here, in this case, this oxygen has lone pair of electrons. So it will attack this here. So with this, what you get is CH3, C, this is OH here, and here you get O, and with the H, oxygen will get a positive charge because oxygen has given electron, COCH3. Now oxygen doesn't want positive charge because it's an electronegative element, it will ask hydrogen to go off. So this will form CH3, COH, OH, O, COCH3. And there are two OH molecules and one carbon, so it will remove water. So it will say minus H2O, it will form CH3, CO, O, CO, CH3. And this is my anhydride. So if you want how this is formed, what you can do is you can say H plus attack on this, it will form H2O plus it will go off, carbon will get a positive charge, and since carbon gets a positive charge, carbon want to get rid of positive charge, this H will go from O and there will be double bond form. Correct? So this is the reaction mechanism for formation of anhydride from carboxylic acid. The next is esterification from carboxylic acid. So for esterification, what we do is we take carboxylic acid and then react with alcohol or phenol in presence of some H plus ions, and it will give you ester. So if you see the reaction mechanism, I have some carboxylic acid and react with some alcohol in presence of some acid H plus. This will give me ester, RCO, R dash, and water molecule. If you want to know the reaction mechanism, how it works is, see, I have this carboxylic acid, I have this H plus, right? H plus has to react here, right? Because oxygen is electronegative and we know that this bond easily breaks in this fashion. And I have R dash OH, oxygen has lone pair of electrons, it will attract this carbon. So with this, what you get is OH, here OH, and here ORH, right? And since oxygen has given electron to carbon, it gets positive charge. Correct? Now this oxygen doesn't want positive charge, it will ask hydrogen to go off. So it will become R, C, OH, OH, and OR dash. There are two OH molecules in this. So what we can do is either this H plus, let's suppose, will be attacked by this guy. So this will become R, C, like this, H2O plus, which is pretty heavy. So what will happen is this will go off, H2O plus. So carbon will get a positive charge. Carbon will get a positive charge. Carbon doesn't like positive charge. So it will ask this hydrogen to go off. Oxygen gets negative charge. Oxygen negative. Carbon gets positive charge. It will form a double bond. This is the formation of ester. From here directly you can remove water. You can say that one carbon has two OH molecule, pretty bulky. So H2O will go off. That is also one process directly. Or you have to say that H plus attacks this OH. It becomes H2O plus. H2O plus pretty bulky, it goes off, right? H2O goes off and carbon gets a positive charge. Carbon doesn't want positive charge, so this asks oxygen to move, sorry, hydrogen to get out. Oxygen gets negative charge and they form double bond. The next is my reaction with PCl5, PCl3, SOCl2. So if you see the OH group of my RCOH, actually, this group will be replaced by chlorine. So we have seen this kind of reactions earlier. So if I have RCOH react with PCl5, what I get is RCOCl, PCl3, and HCl. Similarly, if I have RCOH, this is my carboxylic acid, react with PCl3, I get RCOCl and H3PO3. I get three of these, I need three of this. Similarly, if I have RCOH, again my carboxylic acid, I react with SOCl2, you get RCOCl, sulfur dioxide gas, and HCl. This is most preferred because these gas emits on its own. This is the most preferred method. Let me discuss the mechanism for this. This is RCOOH and I have SOCl2. Sulfur is an electron hungry compound. So what will happen is now this bond will break, it will get a negative charge and this negative charge will be attracted here, and with this what will happen is chlorine will come out. So this carbon gets a positive charge here. So what you get is here, this carbon gets a positive charge, oxygen reacts with sulfur, the double bond here, there is a chlorine here because one chlorine came out. Correct? This is what you get. Correct? Now what will happen is, sorry, there is a OH also here, and this chlorine which came out will attack this guy. Correct? So with this what you get is RC with the OH here, with the chlorine here, and there is a big compound here. Now SO2 gas is pretty easy to go out, right? So what will happen is now, so this H, actually this bond H, right, this will break, this H will come out, this will get a negative charge, and this will also break, carbon will get a positive charge, this will get a negative charge, it will form a bond, and SO2 will come out. So with this you get R, this, right, Cl. Correct? Because see, this forms a double bond here, this OH comes out totally. See, this bond, this forms a double bond, this bond breaks completely, right? And from this SO2 comes out, and again Cl minus again once more comes out, and that reacts with H plus to give HCl. So we have HCl, we have SO2, and this forms a double bond. This is a double bond here, right? You see, This is my double bond, this is the chlorine here. So for clarity, what I can do is I can draw in this fashion so that you don't want to be confused. With this it is clear. See, this C and O, there's a single bond formed double bond, right? This H went out, H reacted with Cl to form HCl, and SO2 also comes out. So this is the reaction mechanism for this. Now we'll discuss the reaction of carboxylic acid with ammonia. So if I have my carboxylic acid, it reacts with ammonia, it will be in equilibrium, it will give you ammonium salt. And then when you heat it, it gives you amide. This is the reaction. For example, I have CH3COOH. This is my carboxylic acid. When it reacts with ammonia, what happens is this becomes CH3COO minus and NH4 plus. One hydrogen goes from here to here, so it becomes NH4 plus and O minus. When you heat this, what happens is the water molecule goes off, oxygen here and H2 here. This becomes CH3CONH. This is acetamide, correct? And this is ammonium acetate. It's ammonium acetate, it's acetamide. Similarly, if you want, you can do this reaction for benzoic acid also. This is benzoic acid. When it reacts with ammonia, it's in equilibrium and it forms this complex compound CO minus NH4 plus, because one hydrogen goes from here to NH3. This forms a ionic compound, and when you heat this, the water molecule goes off and it forms amide. And this is my benzamide. And you see, this is ammonium benzoate. Let me write it. Ammonium benzoate. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.